Hello friends, let us now learn some important points about the brightness gain of image intensifiers. Brightness gain of image intensifiers is that how much brightness of an image has been increased by passing the electrons through an image intensifier. There are two methods for evaluation of brightness gain of image intensifier. The first method is using a Patterson type B to fluoroscopic screen. There is something called as Patterson type B to fluoroscopic screen. So what is brightness gain? So this brightness gain is actually a ratio of intensifier. This intensifier X-ray tube which we have learned in our last class. Intensifier luminescence, if this is divided with the Patterson type B Patterson type B2 fluoroscopy luminescence, then we get something called as brightness gain. Image intensifier or X-ray image intensifier is almost 6,000 times brighter when compared to the Patterson B2 luminescence. Then we call the brightness gain has to be 6,000. This Patterson B2 luminescence which is there, this will change or this will vary from one batch to another. So this is very unpredictable. So as a result, instead of using this Patterson uh, B2 luminescence as brightness gain, instead of this nowadays we started using something called as conversion factor. This conversion factor is mainly recommended by International Commission of Radiological Units and Measurements. They have said that conversion factor is a better word. And this conversion factor, what does this conversion factor mean? This conversion factor is the ratio of luminescence of output phosphor, luminescence that we get from output phosphor to the input exposure rate. Luminescence of output phosphor to that of input exposure rate is called as conversion factor, meaning that the amount of from the input exposure, this luminescence, if you see and you divide it with this input output luminescence, the luminescence that we get from output phosphor divided by the luminescence of the input phosphor, then we get what is called as conversion factor. The output phosphor is measured as candela per meter square. Output phosphor is measured as candela per meter square, whereas input exposure rate is measured as milliroentgen per second. Input exposure rate is measured as milliroentgen per second, and luminescence of outer phosphor is measured as cadmium per meter square. So the conversion factor units are cadmium per meter square per milliroentgen per second. What is this candela? This candela is the luminous intensity. It is actually the luminous intensity obtained in perpendicular direction to the surface of 1 by 6 lakhs meter square of a black body at a temperature of freezing platinum temperature and at a pressure of 101325 Nt per meter square. This is not needed to remember, but still, this is what the candela means. Right. So, this is about the conversion factor. So, brightness gain, which we have seen in just before, we have seen brightness gain, right? So, this brightness gain of an image intensifier, which we have learned in our last class, modern in an image intensifiers will have a brightness gain of 10,000 values very easily, and values are even of even 20,000 are also possible. Whereas this conversion factor usually produces 1% of brightness gain only. For example, if the conversion factor is about 100, then that means in modern image intensifiers or X-ray image intensifiers, the brightness gain is 10,000. I have said in the last class that just before that the conversion rate is equal to conversion factor is equal to 1% of brightness gain. So for example, the brightness gain is 10,000, that is 1% of 10,000, meaning that the conversion factor is 100. So brightness gain decreases. This brightness gain will decrease as the image intensifier ages. As we use the image intensifier again and again and again and again, this brightness gain will decrease. So that means that the patient dose with the old image intensifiers is higher when compared to the newer image intensifiers. So because the patient dose also increases with old image intensifiers, we have to do a periodic check of image intensifiers should be done. A periodic checking of image intensifiers should be done to make sure that it is functioning properly. Next, brightness gain of the image intensifier comes from two completely unrelated sources. This brightness gain comes from two unrelated sources, not one but two unrelated sources. So this brightness gain will come from two things. One, we call it as minification gain, and we have flux gain. We have to learn about minification gain and flux gain separately. So first, what is called as minification gain? Minification gain is reduction in size of the image. Minifying, mini is size. So reduction of the size of the image is called as minification gain. The quantity of gain will depend on relative areas of input screen and output screen. That means you see if this is the input screen, see this input screen is very big. This is input, sorry, this is input, right? So input screen is very big and output screen is very small. So what is minification gain? Minification gain is the diameter of the input screen by diameter of the output screen square whole square, that is to the power of 2. Then we get the minification gain. Minification gain is equal to diameter of the input by diameter of the output and whole square multiplied by 12, multiplied by whole square. Then we call it as minification gain. Maximum, most of the image intensifiers will have an input screen size of 5 to 9 inches, whereas output screen size of most of the image intensifiers will be 1 inches in diameter. And there are some image intensifiers with input of around 12 to 16 inches in diameter also. If there is 1 inch diameter of output screen, then and if there is 1 inch diameter of output screen and think that there is 5-inch diameter of input screen, so the minification gain is almost 25. Now the here the minification gain, both of this is diameter, right? The diameter of input and diameter of output. So minification gain has no units, right? Next, so after this minification gain, minification is decreasing the size. Minification gain is diameter of input by diameter of output whole square will give us the minification gain. So sometimes if the diameter of the input is made to be 9 inches and diameter of output is 1 by 16th, just imagine, then the minification gain will be 9 by 1 by 6 whole square, which is equal to 9 into 16 whole square, which is almost equal to 20,000. So magnification gain is itself is 20,000. So actually, if you have remembered, brightness gain is made up of two things. One, we have magnification gain, and the other flux gain. With only magnification gain, we have got 20,000. So it is a lot. But the problem is that with the decreasing with magnification, the image size will be decreased a lot. So obviously, this is not that desirable, because if the quality though it is increased, because the size is decreased, we cannot see it properly. Even if you try to increase the size through another techniques by using bigger fluorescent crystals or bigger output screen, by increasing the output screen, then if you try to increase this size of the image, this will also decrease the resolution of the image. So as a result, it is not advisable to increase the magnification of the image. Then, after the minification of the image, the next important thing is the brightness gain is also made up of one more factor, which is called as flux gain. So, what is the flux gain? Flux gain is the increase in brightness of the fluoroscopic image. So, what actually happens is whenever the X-ray photons will strike the input fluorescent screen, this produces light. This light photon from the input fluorescent screen goes to the photoelectron. This photocathode. This photocathode will produce electrons, which are called as photoelectrons. The photoelectrons are ejected from the photocathode, and these electrons are accelerated to the opposite end of the tube. The photoelectrons from this edge will all the photoelectrons will meet at the focal point, and from there they are accelerated towards the opposite end of the tube. And once they are accelerated to the opposite end of the tube, these photoelectrons will have an energy because they are accelerated. Anode has more positive potential. The electrons are now accelerated. These accelerated electrons at the output, it will produce at least 50 light protons, light photons. One photoelectron can produce at least 50 light photons. So that is called as flux gain. That is the amount of or the number of light photons which are produced in the output photos fluorescent screen from a single X-ray photon is called as flux gain. So what is the total brightness gain? Brightness gain is equal to the total brightness gain is equal to the magnification gain multiplied by flux gain. So this is called as brightness gain. As we have said, the magnification gain is diameter of input by diameter of by output whole square into flux gain. So just imagine that there is a 9-inch input screen. This is 9-inch input screen and 1-inch output screen. Then in such cases, 9 square into flux gain is obviously 50, that is 81 into 50, which is equal to 4050 is the total brightness gain. So with the help of this brightness gain, we can measure the intensity of the this image X-ray image intensifier. Thank you.